Next, when a metallic surface is illuminated with a radiation of wavelength lambda, the stopping potential is V. If the same surface is illuminated with a radiation of wavelength 2 lambda, the stopping potential is V by 4. The threshold wavelength for the metallic surface. This type of question is very important. The two statements will be given. Based on these two statements, you have to find out the answer. Okay. So the two statements are, the first case. What is the first case? The metallic surface is illuminated with the radiation of wavelength lambda. Stopping potential is V. Okay. So let me write the formula. Okay, let me write the formula. Einstein's equation, EV0 is equal to H mu minus phi 0, correct?
Yes, sir.
So in the first case, the stopping potential is given as V. So in the first case, let me write here, EV. In the first case, stopping potential is given as V. Understood? Clear?
Mm.
And you know that mu is not mentioned in the question, only wavelength is mentioned, correct?
Yes, sir.
So 1 minute, and also they mention about the cutoff frequency, threshold wavelength. Yes, threshold wavelength. So let me do one thing. Right hand side, let me do one modification. S mu minus phi 0. We have studied that S mu 0. Correct? Clear?
Yes, sir.
And they talk about lambda wavelength. So I want to replace this frequency. You know that mu equal to c by lambda, correct?
Mm.
And mu 0 is equal to c by lambda 0. That is okay?
Yeah, ma'am.
Clear?
Yes.
Or for the time being, anyway, you will get two equations. Later, I think you can find out this. 1 minute. Okay, anyway, we can proceed. HC is common in both cases, right? Clear? HC is common.
Yes, sir.
So EV0 is equal to, let me write the formula again. EV0 equal to HC into 1 by lambda minus 1 by lambda 0. Correct?
Okay, sir.
Is that okay? I hope you have understood. So, okay. So let me substitute the value. In the first case, the stopping potential is given as V. Okay, clear?
Mm.
HC is a fixed number. 1 by lambda. In the first case, the radiation having wavelength lambda. Clear?
Mm.
Wavelength of the radiation is lambda. Cutoff frequency lambda 0. Clear?
Okay, sir.
Equation number 1. Now in the second case, the wavelength is changed to 2 lambda. Clear?
Mm.
The stopping potential becomes V by 4. Means V0 becomes V by 4. Clear? Understood?
Okay, sir.
V0 becomes V by 4 in the second case. Right side HC remains HC itself. 1 by lambda, but lambda becomes 2 lambda in the second case. Clear?
Mm.
Can you understand?
Yes, sir. Understood.
Okay.
I
Okay. 1 by lambda
1 by lambda naught.
0. Lambda 0 remains same because it is a cutoff wavelength. Cutoff wavelength is a
For
property
a
of the.
metal, it is
Yes, yes, yes. I got two equations. From this two equation, I have to solve. Yes. Yes, not division. I think if you do the division, will you get yes, 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 yes. So many terms will be cancelled if you do the division.
chance.
Correct. Yes. There's a cancellation will be there. So let us do the division. If you do the division in the left hand side, you will get 4. Shall I discuss that? You can understand.
No, sir. I understood.
HC cancel in the right side. And you do the cross multiplication in the right hand side gives lambda 0 minus lambda divide by lambda lambda 0.
Lambda.
Here also lambda 0 minus 2 lambda divide by 2 lambda lambda 0. Correct?
Yes, sir.
So lambda 0 will be cancelled, numerator and denominator. Clear?
Mm.
You must be careful when you do the simplification, otherwise you will make mistake. But by 2 is still there in the denominator side. Clear?
Yes, sir.
This by 2 go to numerator side. I mean taking reciprocal. So 2 times lambda 0 minus 2 times lambda divided by lambda 0 minus 2 lambda. Clear?
Yes, sir.
Do the cross multiplication. 2 lambda 0 minus 2 lambda is equal to 4 lambda 0 minus 8 lambda. Rearranging, I don't want to explain the simplification step. Rearranging, you will get 6 lambda is equal to 6 lambda equal to 2 lambda 0. Okay?
Yes, sir.
And lambda 0 is equal to 3 lambda. Clear?
Yes, sir.
That is our question. Threshold wavelength is equal to 3 times lambda. Option D is the correct answer. Clear?